module here, we're going to cover the different kinds of storage you will find as services in AWS. And you probably remember from previous lectures when we talked about the different ways of storing data as block, as object, or as file. So this is where this comes into place, right? The way that you store storage pretty much defines the type of service you're going to use, or the way you're going to store data, I should say. But at the end of the day, remember, data is data, right? A file is a file. It contains information. Picture is a picture. It is the way you store the data and the way you retrieve that data that makes up the difference here, whether it's an object, whether it's a block, or whether it's file. Okay, so because of the way you store the data and where you store it also creates ways for you to get to the data. In other words, it makes a dependency on where the data is going to be and the kind of method you're going to use to retrieve it or to write data into the storage. Okay, so that's what makes the difference, among other things, for block, object, and file. Again, at this level, we're not worried about really understanding the nitty-gritty of how block works, or how an object really works. We're more interested in knowing, again, what services are associated with the type of storage, right? Just like when you write something in a file and you use your computer, if you write it to your hard drive, if you write it to a flash drive, you don't really, you don't really look into the details of that, but you know where it's going and you know where to get it from, right? And that's what's important here. Okay, so we're going to look at the 3 types of, or rather 5 types of services that relate to storage. And we're going to start with Amazon Elastic Block Store, EBS. Remember last time we talked, when we talk about compute services, we talked about attaching storage to the instance. And this is one type of storage that you can attach to the instance, pretty much like a hard drive, more or less. Then we're going to talk about another important service that is called Simple Storage Service, or simply S3. That's what the 3 is for, Simple Storage Service. We're going to continue looking at Elastic File System. And we're going to end with another type of storage called Glacier. And then we're going to end it up with Snowball. Okay? So again, it's important that we're going to understand the difference between the different types of storage, like we said before. And then we're going to review the prices associated with this type of storage solutions. So putting into perspective, again, we're looking at the core AWS services. Last time we spent a lot of time talking about one of, well, several of the compute services, but our focus was really into EC2. EC2 is the major of the compute services. We also talked about Beanstalk. We talked about Lambda, right? So now our focus is on storage, okay? And within storage, we found different services, and this is some of the ones we're going to be talking about today. So the first one again is EBS, Elastic Block Storage, and like the name, or store, like the name implies, data is then stored as blocks. Okay. Another difference between or among block files and objects is where they operate and the type of protocol they use to access the data, or either to write it or to read it. Remember, a protocol is just sort of a language, computer language, a method that is used, an agreement that is used, if you will, in order to communicate, right? So each type of storage uses a different protocol to access the data they want. And they also use different hardware, right? Different ways of storing it. Like I mentioned before, just like when you store something in a hard drive, or when you store something in a flash drive, believe it or not, you're using different protocols each time you store it, because each device, flash drives understand a certain protocol, a hard drive understands a certain protocol. So it's the same idea here. So block operates at what is called the OS kernel level. That is the lowest, more organic, the more basic level that you can get into an operating system. Is the basics of what you need to run an operating system, okay? And the data is stored and organized as a array of unrelated blocks. So everything that is stored in a block level storage, like the name implies, is stored in blocks, different blocks of data. And it's accessed over a network as a SAN, a storage area network, and it's using protocols such as SCSI. This is another name for a protocol. It's not important that we know how it works. It's just a protocol, a language used to access that data, okay? File, on the other hand, operates at the operating system user level. It's a higher level than the kernel level. The data is stored in files, is managed as a hierarchy of files and folders, pretty much what you see in your computer when you have a path. And if you have a file, you go and search for the folder where your file is located and so forth. And it's accessed over the network as a NAS, network access system, storage, rather, using protocols such as network file system. So again, block is accessed over a network as SAN using certain protocols such as SCSI. File is accessed over a network as a NAS using protocols such as network file system. And if you remember, we talked when we looked at networking concepts, and when we look at data concepts, we talked about the type of storage in SAN and the type of storage in NAS, right? SAN is a little more complicated, is more sophisticated, but it's just the way that data is stored in each of those type of storage. So the next one then is object. Object operates at the application level. Data is stored as objects, and different from blocks, objects have an identifier. It's called an OID, an object identifier. It includes the data itself, and it includes metadata. Right? Metadata, if you remember, is anything that describes the data itself. When you take a picture, for instance, you have information about the location, you have information about the time of the day and the type of camera you may have used and so forth. That's metadata. So that's a common characteristics of objects type of storage. They include the metadata, and they include an identifier for that data. As opposed to blocks. Blocks don't have that kind of identification. And so they can also be accessed, objects can be accessed using protocols such as HTTP. In other words, you can use a web browser to access that specific type of data. So Amazon EBS allows you to create individual storage volume and attach them to an Amazon EC2 instance. We saw that last time, remember? You can attach the storage when you create the EC2 instance, just like you can attach a hard drive. EBS offers block level storage. The volumes are automatically replicated within the availability zone where they're created. And this volumes is just the unit of a file, right? These volumes can be backed up automatically to Amazon S3. Amazon S3 is the other type of storage that we're going to discuss in a little bit. But the idea is that you can back this up automatically if you want. The normal uses are for boot volumes and storage for Amazon EC2 instance. We know that already. For regular storage, when you when you first, if you're not familiar with what a boot volume is when you first bring a computer on, when you turn it on, the first thing the computer is going to do is going to try to bring the operating system up, right? One of the first things it's going to do is going to try to bring the operating system up. But before it can do that, it has to know where the operating system is, right? Where the initial information for the operating system is, where the drivers for your video, for your network card, and things like that are located. And that's what the boot volume is, right? It has to find that information in order to start the process of bringing the operating system up. So what that means, among other things, that the way you access the boot volume has to be quick, right? Because you don't want your computer to stay on forever until, or to you know, take a long time until it's really on, right? You want to make that very quick. So this type of storage, EVS, is proper for boot volumes because it is fast and it can bring those volumes up very quickly. So other uses also are for data storage, obviously, with a file system, and for enterprise applications. So currently there are 4 types of volume types, of current generation of volume types that you can use. And you can think of this as in 2 ways: how fast you want to access your data, how efficient you want to be when accessing your data, okay? And based on that, you can then choose one of these volume types, or where your data is going to be located, and you can choose how you're going to store that data. Pretty much when you buy a hard drive, right? If you buy the old-fashioned mechanical hard drives, they were less expensive, but they were slower, right? When you buy the more sophisticated solid-state drives, they have no mechanical parts. They're faster, but they're a lot more expensive, right? So it's the same idea here. So in EBS, there are 4 types of volumes that you can choose: provision, IOPS, SSD, and it's called IO1. And IOPS, we'll explain what IOPS is in just a minute. But SSD, again, is a solid-state device. So provision, IOPS, SSD, general purpose SSD, GP2, throughput optimized hard drive or hard disk drive, ST1, and cold hard drive or hard disk drive. Either way, hard drive or hard disk is the same thing. So those are the 4 types. And when you look at, again, when you look at the time of volume type you're going to use, you look at, you know, how you're going to access your data. How fast do you need that data? How efficient you need to be able to retrieve the data. And based on that, you're going to make those decisions. So as you notice here, there's 2 types of SSD backup volumes and 2 types of HDD back volumes, right? So the SSD back volumes are optimized for transactional workloads that involve frequently read and write operations. What that means is that when you look at data, one way of measuring the efficiency, right, is by looking at 1 or 2 things. You're looking at one measurement is called IOPS, and stands for input output per second operations. IOPS, input output per second operations. Or you look at throughput, all right? Each one is measured differently, right? Throughput is measured, normally it's measured in megabytes, or in this case, megabytes is another term here. Megabytes, remember, is like when we look at gigabytes before, is similar, but it's based on the 1024 base instead of 1000 base. And we'll look at that in the next slide in more detail, but that's what that is. So again, going back, there are 4 type of volume types, and 2 of them are for based on SSD or solid state device back volumes, and 2 of those are based on hard disk drive type of devices, right? You see them here. SSD, again, SSD type are optimized for IOPS, for input output per second operations, okay? This is a measurement of how many operations your application can handle per second. On the other hand, HDD-backed volumes are optimized for large streaming workloads, where the throughput is the measurement, is the thing you want to measure, okay? Is your point of reference. And if throughput is a better performance measure than IOPS, then you will go with HDD-backed volumes. You can think of when you buy a hard drive, for instance, it's one of the things that this shows in your hard drive, right? How much data can go in and out in a second. That's what throughput is. And IOPS, in other aspects of it, for IOPS, you're looking at how many operations you can do per second. Now that means, for instance, if you have an application and that application can be accessed by, someone in accounting in a company, and the same operation can also be accessed by someone in engineering, right? They both have different roles, right? The people in accounting are gonna be accessing maybe financial information through that application, and the people in engineering may be accessing some specific data related to the engineering using the same application. And the idea is if someone from each department is using the application at the same time, right, how many of those operations can that application handle in a second, right? And then imagine hundreds or even thousands of people accessing that same application, doing different operations on that application. So that's what IOPS is. How many input-output operations per second you have to do, and that's the measurement. And throughput is just a matter of how many megabytes per second you can retrieve or write to that storage space, okay? So this is a comparison again of the two type of devices, solid state and hard disk drives. And for each one, there is also 2 options: general purpose, provision, IOPS, throughput optimized, and cold. And again, depending on how you are accessing your data or how you want to get to your data, then you will choose the type of drive or the type of category you want to use it with. Each one has a maximum volume size of 16 terabytes. Again, this is one of those terms again, like remember gigabytes is 1024 to the third bytes. Similarly, 1 terabyte is 2 to the 40 bytes. If you remember, also 1 gigabyte is 2 to the 30 bytes. Okay, so that's what that number is. It's just a measurement used a lot in data and transmission information or transmission applications, but it's still data. Okay, so you'll get used to seeing that more often. I know as engineers, we're pretty much used to mega, tera, giga, right? But when you start dealing with data, then you look at GG, teddy, and megi, and so forth. Okay, but that's the idea. It's all based on 10 to the 24th instead of 1,000. So anyhow, when you look at these options here, you have a maximum volume size on each case of 16 terabytes. Okay, and then from there, well, they're all the same in terms of maximum volume size that you can have, and then you start looking at the real differences. For instance, if you look at general purpose SSD, it can handle a maximum IOPS of 10,000 IOPS per volume, and the provision can handle 32,000. The throughput optimized can handle 500, and the cold can handle 250. Okay, so obviously the faster one in this in this group will be 32,000, and the slower one will be 250. Similarly with the throughput per volume, right? You're looking at 160 megabytes for general purpose, 500, and 250 for the call. So you can see that in general here, the call is the slowest one in terms of the number of IOPS and the maximum throughput that it can handle. But there's a reason for that. Okay, call means that this is meant for data that you don't need it often. Maybe you're archiving that data. Maybe it's a backup data. Maybe it's something that you have that you only access very infrequently. So it makes sense to store data under this environment. But if there's something that you need that it has a lot of activity, it has a lot of input and output operations, then you're probably looking at SSD. Okay. And that's another table showing the comparisons of the two. In some of the cases where you may want to use them, we mentioned those already, and it's just another comparison of the two. Another advantage or uses of EBS is in using it as a snapshot for durability. And snapshot means what it says. Okay, if you look at your data and you want to have it available later in case something happens, in case your volume goes down or your hardware goes down, and you want to retrieve it later, you want to restore it, you create every so often you create what is called a snapshot. Okay, and it's just point in time snapshot. So when you create a snapshot, it's tagged at a certain point, so you can go back always and go to that point in time and retrieve the information that it was there when you took the snapshot. Okay, so it's like the name implies. You take a picture of the data at some point in time, and later you can retrieve and go back at that point where the data was. Okay, it's used for durability and in cases of backing up data. It's very commonly used. EBS also uses encryption. Simply means that by using encryption, your data is secure. Okay, every time it's stored, and it implies or actually applies elasticity. By increasing the capacity, you can change to different types. You can go from hard disk to SSD automatically, and you can resize operations on the fly. So it's very elastic to use. So when you begin to look at the cost of using or implementing EBS, you need to start looking at certain things in order for you to understand how much is the cost associated with running what you might need. One of the things is the volume, right? Amazon EBS volumes persist independently from the distance. Well, what does that mean? It means, again, that for example, if the instance goes down or the instance is terminated, if you already saved the data in an EBS volume, it's persistent because you can always go back and attach it to another instance, right? It's there, like a hard drive. As long as the hard drive doesn't go down, if your computer goes down, you can retrieve that hard drive and install it somewhere else. It's the same idea. It's persistent data. The way that this is charged, all volume types are charged by the amount provisioned per month. So you charge by how much data you have, and they look at it every month. Okay. The other thing to look at is the input operations per second, or IOPS, that we mentioned before. And general purpose SSD, the way they charge is they charge by the amount you provision in gigabytes per month. Okay, so however many, at the end of the month, it looks at how many gigabytes or portions of a gigabyte you have in the volume, and it charges you per month. Unless you release the storage, meaning unless you remove it or delete it or whatever. So if it's nothing in it, you get charged nothing for it. Only if there's some amount or some portion of a gigabyte you charge per month. Magnetic is charged by the number of requests to volume, so it's more of a traffic thing. If you storing your data using magnetic type storage, you're going to be charged by the number of requests, read or write. Remember, storing data, it's always a matter of writing or reading, right? When you use your computer, you either reading a file, you might change something in the file. When you change something in the file and save it, you write into that file, right? So it's a constant reading and writing. It's the same thing for all applications. So in the case of EBS volumes or EBS type storage using magnetic values, they charge by the number of requests. Provision IOPS, SSD, are charged by the amount you provision in IOPS. So for example, if you know your application has a lot of traffic, right? And you can predict the maximum number of input-output operations you're going to have, you can then provision that amount, X number of IOPS, right? And then be charged by that, whether you use it or not. And then they're going to charge you a percentage either by day or month that you use it. So that's what's called provision, because you kind of saying how many IOPS you predict you're going to use and then pay for that. So the next thing you're going to look at in terms of pricing is snapshots. You pay for those snapshots. They act to the cost of maintaining EBS in your environment. But you pay also for, because the snapshots, when you take a snapshot, remember, it's like taking a picture of your status of your data, right? Those snapshots that are created are automatically stored in S3, which is the other type we're going to be looking a little later. So you pay for storing into S3 per gigabyte per month, okay? And you also pay for the data transfer. Inbound data transfer is free. In other words, when you write into EBS, you don't pay for the data transfer, right? You pay for what's in it at the end, right? At the end of the month, remember, you pay per gigabyte, but as long as you're writing in to that storage space, the inbound process is not charged for. Okay. However, they charge you for the outbound transfer, right? Well, that's the way it is. Writing data into the volume is not charged. They charge you for the amount you keep inside, if that makes sense. But getting it out, you pay for it. Okay, so the outbound traffic is like, you know, when you cable company or whoever tells you, you know, you had this many megabytes or whatever gigabytes of download per month, but you have X number of gigabytes of uploading per month, right? Uploading is always more expensive, correct? Remember that? Same with your phone, right? It's the same concept here. All right, so features of EBS is persistent. Remember why we say it's persistent? Because you can move it, right? You can, even after it's detached from an EC2 instance, you can still get to it if you make the proper setup. You have hard disk drive and solid state drive types. Is replicated in the same availability zone. It's easy and uses encryption, easy and transparent encryption. The volumes are elastic because you can always automatically increase or decrease. And it's using backup through snapshots. Okay, so it's your first exercise. Make sure you complete it. And again, the answers are in the back at the end of the module. All right, so now let's look at the next type of storage, which is called S3. And I'm going to quickly stop this for just a second. Okay, so we're back, and we are going to now discuss the S3 service. Okay, so remember, EBS uses block storage, right? Block, meaning that data is stored in blocks, and it uses a certain type of protocol to access it, right? This other type of storage, S3, is really it's also called cloud storage in many cases, because it's the type of storage you use in the cloud. Object, it uses object storage. And that's why it's commonly used or referred to as cloud storage. So S3 is a managed cloud storage solution designed to scale seamlessly and provides 11 nines of durability. And that's 11 nines, right? That's pretty durable, if you will. It's managed again because, again, it's something that Amazon takes care of it for you. You just put data in it, you retrieve data from it, and the rest is managed by AWS. All right? You can store as many objects as you want. That's one of the characteristics of object storage. It's as much storage as you can have. The bucket names must be unique across all existing bucket names in Amazon S3. And we'll see what that means later. The reason for that is because when you store data in blocks or in files, you normally have something that is really meaningful to you, right? Like the name of the file is very simple. Well, the name of the files when you use objects are a little more complicated. So they must be unique in order to be accessed. Because it uses HTTP. HTTP uses the web, right? It's a web protocol, a browser protocol. And so those names must be unique. Just like when you access a website, the website name is unique. Well, the name of the file, the buckets, has to be unique in order for them to be accessed. And you'll see that in a little bit. Amazon S3 cannot be used as a bootable drive. Remember, we talked about what a bootable drive is, right? You can boot a computer or a device from it. It's not that, for one reason, it's not fast and it's not meant for that purpose. Data is stored redundantly, meaning that it replicates the data in different availability zones automatically. You access Amazon S3 with the Amazon Web Services Management Console. You can also access it through what is called software development kits or through third-party solutions. Software development kits are just software packages, okay? Meaning that you can use, instead of, remember last time when we went through the management console to create the EC2 instance? Well, we can do the same thing and go through to the management console and create or access S3 storage, right? So that's one way of doing it. And what it's saying here is that also you can do it through software. You can write code through what is called software development kits to access the same S3 storage, okay? Object uploads or deletes can trigger notification, workflows, or even scripts. So you can set it up so every time you upload an object or delete an object, you can be notified, or you can bring something else up. You know, that's what our workflow is, through scripts, through little pieces of software. The data can be encrypted automatically. Storage class analysis, what is called Amazon S3 Analytics, can be used to analyze the patterns and how the data is being used. So it's very useful for that purpose. And just like we looked at EBS providing different levels of storage, well, there's also 4 classes of object level storage. And they're called Amazon S3 Standard, Amazon S3 Standard IA. IA stands for infrequent access. We'll explain that in a minute. Amazon S3 One Zone infrequent access, and Amazon Glacier. Okay, so those are the 4 types of object level storage in S3. Standard means that it's a high durability, availability, and performance. It provides low latency, meaning it's the fastest. The lower the latency, the fastest you can access the data and retrieve the data, and high throughput. Okay, in other words, the amount of megabytes per second or megabytes per second that you need to handle is high. You can support high throughput. It's really standard for cloud applications and content distribution, mobile and gaming applications, and big data analytics. Okay, it's very popular for cloud applications. The next one was standard infrequent access, IA, and that means that data that is accessed less frequently, right? But still requires rapid access when you need it. When you, in other words, is not as fast as S3 standard, but is the next level up. If you have data that you need to access less frequently, this is the choice you'll have. It still has high durability, high throughput, and low latency, but not as high standards as the S3 standard. Okay, it has a low per gigabyte storage price and per gigabyte retrieval fee, and is ideal for long-term storage, backups, and for disaster recovery. And that's the idea, right? When you backing something up, you're not accessing that data unless you need the backup. And so that's why it's called infrequent access. Then the other type is one zone infrequent access. Well, in the case of standard, or these 2 standard cases, the generic standard and the standard infrequent access, the data is replicated among 3 different zones automatically by default. Well, but you can choose not to do that. And if you do that, it's going to be just on one zone. So it stores the data in a single availability zone. It's still an infrequent access type, but as you can imagine, it's cheaper than the other 2. So this is again for data that is accessed less frequently, but requires rapid access when needed. So even though you don't need to get to it maybe every month, every 6 months, but when you need to get to it, you need to get it quickly. You understand? So even though you're not using it very often, whenever you need it, you want to get it fast. So that's when you want to use these cases. And like I said before, all the other object storage classes that we talked about before store data in a minimum of 3 availability zones. This one stores data in 1 availability zone. Okay, and it's just, again, it's going to be cheaper. The other one is called Glacier, and it's a low-cost storage service for data archiving, data that you only access very infrequently, and not only very infrequently, but you may not need it. You may not need to get it very quickly. Okay. It's cheaper than the other on-premises solutions or any on-premises solutions that we may be aware of. So these are the 3 types of storage classes: standard, standard infrequent access, standard one zone infrequent access, and Glacier. So Amazon S3 stores data in what is called buckets. Remember, EBS, which is Elastic Block Storage, stores data in volumes, right? In volumes. S3 stores data in what's called buckets. Okay, buckets are just the logical container for objects, and they're essentially the prefix of a set of files. And as we mentioned before, they must have a unique name, independent of all the other files in S3, and we'll see examples of that in a minute. You can have 1 or more buckets in your account. A bucket can have unlimited, almost unlimited amount of objects in it. For each bucket, you can control access. In other words, who can create, who can delete, who can list the objects in the bucket. You can also view access logs for that bucket and its objects and choose in which geographical region you're going to store the bucket and its contents. In S3, files are called objects, as we know. In EBS, files are called blocks, right? EBS. In S3, files are called objects. Once you have a bucket, you can store any number of objects inside of it. So buckets store objects, and volumes store blocks in EBS, okay? An object is composed of data and any metadata that describes that file, as we mentioned before. To store an object in Amazon S3, you upload the file you want to store into a bucket. So in this case, to upload your data, whether it's photos, videos, any document, etc., you first create a bucket in one of the regions, right? And then you upload that any number of objects into that bucket. So you create a bucket within S3. And then once you create that bucket, you can put your files, which in the case are objects, in that bucket. The notation for the buckets are as follows here, right? They have like a URL name associated with them. So whenever you name a bucket, the first thing it's going to have is, of course, HTTPS : // The first thing after that is going to be the code for the region where that bucket is created. As you can see here, right? This corresponds, in this case, for Tokyo region. And then it's going to have the typical name Amazon .amazonaws.com / and then the name of the bucket. Okay, so the name of the bucket. So this here, the region tells you where the bucket is created. And the next piece of information will tell you the name of the bucket. Okay. From there, you can go down another level, and after the bucket name, you have / the name of the object file, right? So this is the notation, as you can see at the bottom here, that you will use to access this file. Okay, this is the key for the object. It's also called the key of the object. Okay, so you have the region where the bucket is created, AmazonaWS.com, and then the name of the bucket, and then the name of the object, which is also called the key. Right? So this will uniquely, this whole thing here, this URL will uniquely identify where that file or that object is located in S3. Okay? When you create a bucket in S3, it's associated with a particular AWS region, as we saw. And whenever you store data in a bucket, it is redundantly stored across multiple facilities within that selected region. We said it stores in up to 3 regions, as long as you don't have one zone chosen. S3 is designed to be durable, even in the case of concurrent data loss in 2 AWS facilities, right? Because even if you lose 2 zones for whatever reasons, you still have a third one. So it makes it very durable. And this shows that example, right? You create a bucket called my bucket name, and you put a file here, welcome MP4, media / welcome MP4. And then when you create that object, it's replicated in 3 different zones within the same region, okay? Is redundant. Amazon S3 will automatically manage the storage behind your bucket even as your data grows, because it's a managed system, right? You don't have to, you don't have to do anything automatically to grow the size of the bucket, or you don't have to do anything automatic to reduce the size of the bucket or to change anything. If you put more data in, more objects in, it's going to grow automatically. This allows you to get started immediately and have your data storage grow with your own application. You don't have to worry about, you know, how am I going to get more space or anything like that? Or how am I going to manage having more space, right? Which can become a problem. For instance, if you have a hard drive in your computer and eventually you're running out of space on your hard drive, well, it's not that easy to change. You know, if you have one single hard drive, to change your hard drive to a much larger one. Well, it's easy, physically it's easy to do. You just buy another one and stick it in, but it's not, you have to do some of the things to make that work, right? You probably have to stop your computer, reinstall your hard drive, make your computer recognize the new hard drive, move your data into the new hard drive. And yeah, you increase the size of the hard drive, but if you think about it, it's not that easy. With this service like S3, that never happens. You put more data in, the system grows with you, and you have to do nothing. So we also scale to handle high volume of requests. You don't have to provision the storage or throughput, and you only be billed for what you use. So again, you don't have to, you know, let's say all of a sudden the way you're retrieving the data it has more demand. And again, let's go back to the example of a simple hard drive in your computer, right? If you have a very slow hard drive, it's fine if you're doing something like word processing. But if you have a gaming application or a very high-end application that uses a lot of read and write, well, that hard drive may be too slow for whatever you need to do, right? And so, again, that may require you to change the hard drive, not because it doesn't have enough space, but maybe space, I should say, but maybe because it's too slow and it's handling the data very slowly. Well, same thing here. With S3, you don't worry about that because it's managed and it grows as the storage grows, or it grows as the volume of requests grow. It supports HTTP or HTTPS access. Again, HTTP is the protocol used for web and web browsers. The S simply means that it's secure, right? S3 packet names must be globally unique and DNS compliant. Domain name service, remember domain name services is what translates a simple domain name into an IP address, right? But they must have certain things that they must follow, right? And for instance, packet names should not contain uppercase letters. They should not contain underscores. They should not end with a dash, and so forth. They should be between 3 and 63 characters long. Other things cannot contain dashes next to periods, cannot contain periods, right? That's for the bucket names only. So those are the rules you need to follow when you name a bucket. If you go outside this guidelines, it'll give you an error. It'll say that something's wrong with the name or something like that. So with S3, you can access your data anywhere through, through the management console, like we said before, like one of those services. Through SDKs, we mentioned software development kits, which is a package of software that already developed that you can use to access your data. And through another form that is called CLI. CLI stands for Command Line Interface. Command Line Interface. Some people like this, especially Linux or Unix users who like to use commands. As you know, Windows is a GUI-based operating system, right? GUI meaning that you use your mouse and you click here, you click there, and you get to your applications that way, right? It's very visual. But Linux and similar systems are not GUI-based. They're not very visually accessible. They use command line interfaces, but you can get, you can get to a file whether you use Windows or whether you use Linux. And in one case, if you use Windows, you'll get to that file using your mouse, and pictures to get to the clicks to get to the file. And you can get to the same file if it's in Linux. You can do the same thing, but you'll have to use some commands to get there. And this is what that is, CLI. So it's an option for some users to get to the data using commands, all right? It's called CLI, Command Line Interface. It's just another option that doesn't use the management console. So common use cases for S3 is storing application assets, what's called static web hosting. If you never heard the name static web, there's basically two types of websites, either dynamic or static. Static website doesn't mean that it doesn't have anything that changes. I mean, it only means that, for example, to give you an opposite example, a dynamic website will adapt to some of your customizations, for instance. Like if you already visited that website, it'll know the next time you go in, it'll know who you are kind of way, and it'll adapt. You know, like when you go into Amazon and buy something, right? It probably tells you the last thing you bought, and it probably bring things similar to the things you bought last time. That's a dynamic website, right? It is pushing information, it's changing the information depending on who you are. A static website is not. It's just, you know, it doesn't change much. It may, you know, it still has graphics, it can have videos and everything, but it doesn't really adapt much to the user, for instance. It's also, S3 is also good for backup and disaster recovery, gaming, and for big data applications. The pricing, well, you pay only for what you use. This includes, you pay gigabytes per month, the number of gigabytes per month. Remember, you only pay for transferring out to other regions. Requests are defined as put, let me change this in the, okay. The requests are defined as put, copy, post, list, and get. What this means really is, you know, you write the data into a bucket, right? You read data from a bucket. You copy data, you list it, right? It's the same, it's basically the same thing here. So these three commands or these three request types, put, post, and list, are involved in uploading files, right? So it's sort of like writing type of requests, right? Putting is like request writing, and get is like reading. So get requests occur when you download files. So put, post, and list are related to the uploading of files, and get is related to the downloading of files. So you do not have to pay for, as a general rule, you only pay for transfers that cross the boundary of your region. You don't pay for transfers into S3, remember? Into the S3 buckets, you don't pay. You only pay for data that comes out of the bucket. Okay. The bucket is owned by the AWS account that created it. By default, you can create up to 100 buckets. That number can change, by the way, in each of your AWS accounts. That's the default number. That's a huge number. But if for whatever reason you need more buckets, you can increase your account up to a maximum of 1,000 buckets, but it has to be submitted as a special request. S3 objects can range in size from a minimum of 0 bytes to a maximum of 5 terabytes. Okay, so your maximum object size can be 5 terabytes. In order to estimate S3 costs, you can look at the following factors. You can look at the type of storage class you're going to use. Standard storage gives you 11 nines of durability and 4 nines of availability. And standard and frequent access gives you the same number of nines of durability, but gives you 3 nines of availability, a little less, right? You know what that means in terms of a year, for instance, right? If something happens. You also look at the amount of storage, the number and the size of objects, and the type of storage. Another factor when considering pricing in S3 is the requests, the number of requests. And then again, like I mentioned before, you typically look at the type of request, get, put, and copy. Get is similar to reading. You retrieve an object from Amazon S3, you might have read access to use this operation. Put is like writing, basically. Adds an object to a bucket. You must have writing permissions or a bucket to add an object to it, but doesn't the names given to those operations. And copy, of course, creates a copy of an object that is already in S3. There are different type of rates for GET requests than other requests, and depends on other things like maybe the region you're in and other factors. You also pay for data transfer. Pricing is based on the amount of data transfer out of the Amazon S3 region. Remember, the key is, again, that data transfer is free, in is free, but charges for data transfer out is not. So you charge for data transfer out, okay? Okay, so reviewing S3 is a fully managed cloud storage service. You can store a virtually unlimited number of objects. You pay for only what you use. You can access your data at any time from anywhere. And that's the nice thing here, see. Just like you can access any website from anywhere as long as you have a browser, right? You don't have, you know, you can use your phone, you can use your smart device. It's the same thing with S3 objects. It can be accessed from just about anywhere. Amazon S3 offers is very secure controls. In fact, you know, you actually using objects, whether you realize it or not, Facebook, Instagram, Spotify, and all those type of storage uses objects, okay? And you can see that in many cases when you look at a picture on Instagram, it has a lot of metadata associated with it, right? Spotify files have a lot of metadata associated with it. Well, those type of files are stored as objects. So they're used everywhere. That's your exercise number 2. Again, take a look. Exercise number 3. Pause this if you want and answer it. And number 4. Okay. And then this brings us to the other type of storage called Elastic File System, or EFS. And again, like the name implies, this is a file storage type, right? We looked at EBS as blocks. We looked at S3 as objects. Well, EFS is a file storage type. It's very usable for big data and analytics, media processing workflows, and similar applications. It can handle very large files at the petabyte scale. It has low latency, meaning, you know, you can access it relatively fast. It offers shared storage. It offers elastic capacity, and it supports network file system, because remember, this is a file storage type, so it supports NFS, right? Remember, we looked at that before. It's compatible with all the Linux-based images in Amazon EC2. So the main difference here is that EFS is for Linux-based applications, okay? Again, in the EFS architecture, you have Amazon EC2 instances running in multiple availability zones within the same region, right? Here you have one region, which is the larger rectangle, and then we can identify 3 different availability zones: Zone A, Zone B, Zone Z. So we have 3 different zones within the region. And so the files can be accessed. Many users can access and share a common data source through this Amazon EFS, right? So even if users are located in different regions, in different zones, I should say, then they can still share those files using EFS. It makes it very convenient. This is a picture of the difference of the three comparison, S3, EBS, and EFS. Again, I'm going to leave you this as a reference for you, but we have discussed the major difference among the three. The major difference between S3, EBS, and EFS, again, is that EBS is going to be used for Linux type applications. Okay, but and you can see the availability of S3 and EBS is pretty much defined. But for EFS, there's no service level agreement as to how available that is. So it's another thing to keep into consideration. All right, and this shows again more of the differences and the similarities among the three type of data storage services. Right? S3 again uses objects, EBS uses blocks, EFS uses files. All right. So again, not much we have to say about the EFS other than this basic characteristics, that is file-based and that is mainly used for Linux-based applications, and it can handle really, really big amounts of data. Okay, at the petabyte scale. So that brings us to the last piece of storage type that we found using S3, and that's Glacier. Glacier is a data archiving service. It's designed for security, durability, and is very, very low cost. It's designed for, again, 11 nines of durability for the objects. It's an S3 type, so it uses objects. Supports data encryption of data in transit and at rest. In transit means that data is going to be encrypted as it goes from destination A to destination B. At rest means that it's going to be encrypted only when it is at the destination, and we'll get into that when we get into security. But the main thing here to understand is it supports data encryption. There's a feature called the Vault Lock that enforces compliance with a lockable policy. And what that means is that if you lock a file using the Vault Lock feature, it's very difficult, almost impossible to make changes to the volumes. Vault Lock policy on a vault means that after it's locked, the policy cannot be overwritten or deleted. So it makes it almost impossible to change the contents of a vault. Extremely low cost. It's ideal for long-term archiving, and it has three options to access the archives, either through what's called expedited access, standard access, or bulk access. And that means that, again, remember, Glacier is used for the purpose of storing data that you don't use often, right? Like if you're backing up data, and something happens and you need to recover the data, or something doesn't have to happen, but let's say you have to retrieve data from records from 3 years ago that you store in Glacier, right? That you don't use all the time, but then you got to go back and use them. Well, how you're going to get to those to that data depends on the type of option you choose, whether it's expedited, standard, or bulk. That means that if you need to get to the data will be there, but how fast you're going to retrieve it, it's going to go from minutes to maybe several hours, depending on what these choices you make. So Glacier data archiving means that although you can store your data at extremely low cost, even in comparison to S3, you can now retrieve your data immediately when you want it, okay? It's not an immediate retrieve. Remember, with S3, you can still retrieve the data rather fast, even if it's in frequent access or standard access. the data can still be retrieved, it has low latency. Well, Glacier is designed not to be able to retrieve the data fast, and that's just the way it is designed. That's what is the cheapest way of storing data. Data stored in Amazon Glacier can take several hours to retrieve if you choose that option, which is why it's ideal for archiving. Archiving data can only be, or it's only meant to be accessed, very infrequently. You don't need something right away. So there are three Amazon Glacier terms that you should be familiar with. Archive. Well, an archive is any object, such as a photo, video file, document that you store in Amazon Glacier. It is the base unit of storage in Amazon Glacier. So a file, in other words, in Glacier is called an archive. It has its own unique ID, and it can also have a description. The vault is the container of archives. When you create a vault, you specify the vault name and the region in which you would like the vault to be created. So think of, again, remember how objects are created in volumes. Objects are created in buckets. Again, objects are created in buckets. Blocks are created in volumes, right? Archives are created in vaults. Okay, it's just a different name depending on where you are putting your data and what type of data storage you're using. And then the vault access policy means that it determines who can and cannot access the data stored in the vault, as well as what operations can you use and not use to retrieve your data. You can also have a vault policy to make sure that the vault cannot be altered. Okay. There are three options for retrieving data that we mentioned in a couple of slides ago. It depends on the timing associated with how you're going to retrieve that data. And these are expedited, standard, and bulk retrievals. Expedited means that you can, the retrieval of data is typically made available within 1 and 5 minutes. It's the most expensive one. So that means that once you need to access the data, you're going to have to wait from 1 to 5 minutes to actually get it out. Okay, again, but that only means that you're going to be able to start getting the data out. If you have gigabytes of data, of course, or terabytes of data, it's going to take a lot longer to get it out. But that only means you're going to start getting to the first byte, if you will, within 5 minutes. Okay, it's the most expensive way of doing this. The standard, you typically have the data available from within 3 to 5 hours. It's less than the expedited case, but it's more of a for bulk, right? It's more than bulk, I'm sorry. It's the middle cost type. Bulk is the cheapest one, and that means that your retrieval will be complete from 5 to 12 hours. It's the lowest cost. So in Glacier, to store and access data, you can use the console again, just like we did when we created EC2. There's only a few operations, such as creating and deleting vaults, and creating and managing archive policies. But a lot of the operations to access Glacier use what we call before the command line interface, or what we call before the SDK, so software development kits. Software development kits is not something that is in the range of knowledge for this class, but again, it's just pieces of software that can be used to access the Glacier data. Another name or another use of another form of accessing the data is also called API. API, again, is just application programming interface. It stands for application programming interfaces, and it's just software used to access the data. You know, again, the best way to put it is to put it in context. As a comparison, you can access Glacier through the console, right? But there are certain things you cannot do through the console. You have to use some sort of programming to get to that operations. So, and these are the options for the programming ways of accessing. One is called APIs, Application Programming Interfaces, SDKs, Software Development Kits, and what we also mentioned before, Command Line Interface, which uses commands to access the data. You actually write, little commands to access it. Okay. Again, the details of that is not important. What's important that you know that these are the ways that you can get to Glacier that may not be available through the console. Okay. So again, in order to get to your data, you can use these 8 SDKs that we mentioned before. They're based on Java or .NET programming type. And you also use what we call the RESTful web services. Again, it's just another set of software type of access that you can have to get to certain portions or to certain applications within Glacier. The life cycle policy brings us to that point. Amazon S3 life cycle policies allows you to delete or move objects based on age. That's a very common way of using S3 and Glacier in combination. And you can see the application here. You can reduce overall costs because remember, when you're keeping data in S3, you're paying for the data you keep in there, right? But as time goes by, that data may not be as important for you anymore, or may not be as needed immediately for you anymore. So there are policies that you can implement called life cycle policies where you keep data. For example, you keep this data for 30 days in S3 standard. Once the 30 days is passed, you can move it into like a standard infrequent access. And after 60 days, you move it into Glacier, right? And if possible, after a year, you may even be able to delete that, okay? Now, it doesn't have to be the exact same way or the exact number of days, but it gives you an idea of what a life cycle policy is. And the idea is that, the longer you keep data in S3 standard, the more you pay for that, right? Because the more your data grow, the more you're going to be paying. So the idea is that you move data you don't need that often into some of the other cheaper ways. In this case, standard infrequent, keep it there for a longer period of time, and then eventually you move it to Glacier. And then, you may keep it in Glacier forever if you think you're going to need it sooner or later, but you can also delete it, if you will, after some point. So this is not a must, but is a recommendation for what it should be implemented in order for data costs to be reduced. So a comparison, S3 and Glacier, they're both object storage solution. S3 is designed for frequent, low latency access to your data, while Glacier is designed for low cost, long-term storage. For infrequently accessed data, the maximum item size in S3 is 5 terabytes, but in Glacier, you can store items up to 40 terabytes in size. Because S3 gives you faster access to your data, the storage cost per gigabyte is higher than it is with Amazon Glacier. Both services have per request charges. Amazon S3 charges for put, copy, pause, list, and get. Remember, that's the equivalent to uploading things. While Glacier charges you for upload, charges for upload and retrieval, sorry. So they have similar ways of charging you for that. So it's something to keep in mind. Amazon Glacier was designed for less frequent access to data. It costs more for each retrieval request than Amazon S3. Both the cost per retrieval and the cost per gigabyte are higher for Amazon Glacier. There's another comparison of the two. There's no limit for data volume. The latency in Amazon S3 can be milliseconds. The latency for Glacier can be minutes to hours. We just look at the different way expedited and the other ones that we looked at. Will bring you from minute to hours. The item size in Amazon S3, the maximum is 5 terabytes. In Glacier, the maximum is 40 terabytes. Amazon S3 is more expensive per gigabyte per month than Glacier. Your bill requests for put, copy, post, list, and get. But in Glacier, you only charge for upload and retrieval. Retrieval pricing is less expensive in Amazon S3, but it's more expensive in Glacier. Okay. Another comparison, server-side encryption. Again, server-side encryption is about data encryption at rest. That is, Amazon S3 encrypts your data at the object level as it writes it to the disk and in its data centers. In other words, like if you're using a computer, for example, and you're writing data onto a file in your local computer. Think of your local computer, right? It's not leaving your computer, right? It's staying in your computer. Well, that's what it's called, this encryption at rest. Because as you are creating the data, and the data is not really moving out of your computing, the data is being encrypted, right? Encrypted means that it's being just making secure. Nobody can just read it unless they have keys to read it. So that's what encryption at rest means. And the other way is that, you know, you can be writing data to a file or and you can be saving that data, but if that data is leaving your computer, right, and then it's going to be encrypted when it's leaving the computer, right? Not while you write into the file. That file, but when it leaves your computer, like if you're writing, you send an email or something, it leaves your computer, then it's going to be encrypted. So those are the two types. But anyhow, with S3, you have server-side encryption. Amazon S3 encrypts your data at the object level as it writes it to disk in this data center, and decrypts it for you when you access it. Client-side encryption is the cryptographic technique for encrypting data on the sender side before it is transmitted to a server. Okay, so again, that means that you know, if you're writing something in your local computer, it's being encrypted as you write to it before it's even transmitted to a server. Another important difference, Amazon S3 and Glacier encryption, like we said before, both transfer data over HTTPS. Any data archived in Glacier is encrypted by default. With Amazon S3, your application must initiate server-side encryption. So Glacier encrypts by default, S3, you must initiate it. Server-side encryption with S3 managed encryption keys uses multi-factor encryption. It's just another fancy way of saying is the encryption is stronger than other types. Amazon S3 encrypts each object with a unique key. It's an additional safeguard. It encrypts the key itself with a master key that is regularly rotated, and is used as one of the strongest types of ciphers available. In other words, the ways of encrypting. It's called the 256 Advanced Encryption Standard to encrypt your data. And again, that only means that your data is being secure, right? AES is one type of one way of encrypting your data, making it invisible, right? Just putting a lot of wraps, a lot of envelopes with your data, where your data resides. The more envelopes you put, you know, and your data goes in, the more difficult it will be to get to your data. That's what encryption really is. But in order to open up that envelope, or think about it maybe in terms of boxes with a key, the larger the box, you need another key. The box, you put that into another larger box, you need another key. So the more keys you have, the more boxes you use to put your data in, the more secure it'll be, right? That's what encryption is. And all this other way of saying this, 256-bit data encryption means that it's more secure, more layers before you can get to the actual data. Okay. Also, S3 and Glacier use a service called AWS KMS, Key Management Service, combines secure high-level hardware and software to provide a key management system scale for the cloud. And it also uses customer master keys to encrypt your S3 objects. Again, these are all the types of encryption that you have available for you to make your data more secure. You can use these keys to protect your data in Amazon S3 buckets. Okay. All right. A little more information on encryption again. Just another way of, again, making your data secure. With an encryption key you provide as part of your request, Amazon S3 manages both encryption as a write to disk and decryption when you access your object. So encryption is the idea of you know, putting all those layers, or putting your data into all those envelopes, or putting your data into all those boxes, right? And decryption is the purpose of getting all those boxes one by one, or getting peeling that onion one layer by one layer until you get to the actual data. So you know, when you create a file, it's called clear text if it has no encryption in it. So it can, you know, if I write a document, for example, in Word, and I gave you that document as a Word document, you can open it up as a Word document and you can see it, right? It's the same thing. If I add encryption to it, however, you cannot read this document unless you have the key, right? Well, so when you encrypt something, you create a key to encrypt that file, right? So after it is encrypted, right, it's locked. You cannot read it. I may try to open up with Word, but it won't recognize it. Okay, even though inside there might be a Word document. Well, in order for me to read it and get it back, I need to decrypt it, right? It's the decryption portion of it. So I will need to know what the key is to open up that lock and see it again. So that's what encryption is. And how you do this encryption and how you do this decryption, there are many methods for doing that, okay? And this is what this couple of slides have mentioned. There are many techniques to encrypt. There are many techniques to decrypt. There are many ways to manage those keys, so you can always have access to your data at the end. Some are more sophisticated ways than others. And so that's what that means, you know, different ways of encrypting, decrypting. But the idea is the same. At the end, you're going to get to your actual file if you know the key. Okay, so this shows again their idea of server-side encryption. In S3, encryption is an optional step. In Glacier, encryption is done by default. Okay. So data in Glacier can be accessed with another service called AWS IM. We haven't discussed IM yet, but you'll see how you can access data with this other service by creating accounts, really creating accounts, creating permissions so that you can access the data in Glacier. But before that, you have to have accounts, you have to have security, you know, you have to be assign a password and so forth. So again, Amazon Glacier encrypts your data with AES 256 encryption. Again, this is a flavor of encryption. Is one of the more common, more popular ways of encrypting data, okay? And then Glacier manages the keys for you. So when you encrypt something, you create a key, right? You have to know the key in order to decrypt it. But you can do that with Glacier. Glacier will manage those keys for you, so you don't have to remember it or keep them all the time. So Amazon Glacier is a data archiving service designed for security, durability, and extremely low cost. It's priced per region. Depending on the region, you're going to see different prices. Extremely low cost and designed for long-term archiving, and is designed for 11 nines of durability for the objects. So this brings us to exercise 5. And the last service we're going to be looking at is Snowball. And first, let me describe what Snowball is. Snowball accelerates transferring large amounts of data into and out of an AWS physical storage devices, bypassing the internet. It's useful for migrating data from an office or data center to the cloud and transferring large amounts of data to or from S3 for backup recovery purposes. Well, what Snowball really is a big box. Okay? It's a big physical box. You can see it here. And it's useful for companies, for instance, that may want to first move to the cloud and they have large amounts of data, right? And, you know, if they have really large amounts of data, it may take days, weeks for them to transfer that data over the internet. Okay? It may take too long. Or they may not want to transfer data over the internet for security reasons. So what AWS does is it says, well, we'll send you this device. It's a big device. It's secure, by the way. It's physically secure in different ways. And they send it to the company, and then the company puts the data into this device, and then they ship it out to AWS, ship it back to AWS. And when it gets to the AWS data center, they're gonna retrieve that data and put it in the company's cloud. Okay, so it's a physical device. It doesn't happen over the internet. It's transferring data from a physical location to the cloud through a physical device, like a big hard drive. Okay. So it's useful for distributing large volumes of content to customers. You can then AWS, when it gets to the facility, what AWS will do will transfer the files that you put in Snowball onto S3 buckets. The data is encrypted, and the sizes of these devices can be from it can be 80 terabytes or 50 terabytes. Those are the sizes at the moment. That's the amount of data it can hold. Then we have Snowball Edge. Well, it's similar to Snowball, but it has a few other features. The Snowball is designed to transfer large amounts of data between environments in S3. It has the same features as Snowball, can be attached to EC2, perform Lambda functions, faster network speeds, pre-configure, and does not have to be connected to the internet. Processing and data collections can take place within isolated operating environments. So you can have this. And by the way, the size of Edge is much larger than the sizes of the regular Snowball. As you can see, you can have up to 100 terabytes, and it's compute optimized. It's a lot faster to get the data, and it's Edge compute optimized with GPU. So it's a lot faster. It's just another option. It can handle more data, up to 100 terabytes, and it can be used to handle data faster. Okay. For instance, if for whatever reason you need to move data to a specific location, geographic location, you can use this service, and that will make your data available real quick once it's stored into this device. And then there's the old extreme, right? This is called the snowmobile. Well, the snowmobile is an actual truck. You can see is a real actual truck. If the amount of data you need to transfer is really huge in the exabyte scale, then you use this truck. Yeah, you can transfer up to 100 petabytes per snowball. So we go from a snowball, right, which is an actual device. Think of it as a hard drive, huge hard drive, but you can only, well, say only, but you can store 80 terabytes to 50 terabytes. If your sizes are growing and you need faster transfers, you will use Snowball Edge, okay? But if the amount of data you need to transfer is really huge, humongous, then you use the snowmobile. And the snowmobile is a truck that will physically bring in a truck to your location, very secure. It looks like this. There's no signs or anything saying that you may have some real important data being transferred. It doesn't say anything. It doesn't have any logos, anything, right? It's very secure. It has a bunch of security in place in order to retrieve the actual data in the devices. So the AWS will send the truck to your location. They will then transfer all your data onto that truck that has, you can have up to 100 petabytes of data. And then it'll bring it back to AWS. And then once it gets into AWS, if your cloud is already set, it will put it on S3 or whatever you want to put it in. Okay. So those are the three. And those are the difference between the three. All right, and that brings us to the end. These are the answers to exercises. There's a little video here that goes over the storage options that we discussed. I will suggest you look at that if you get a chance. It's not required, but it will give you a lot of information, and it may clarify some of the things that we discussed in this module.